Okay, so then these are the answers to the quiz, section 2.4 only, and there's two versions. So did you find it already? Yes, okay. So this version is the one that has x squared minus 14x plus 3. So check to see if that is the version that you have, please. Okay, so for those who have that version, the answers are number 1, C. Number 2, f of x over d of x equals x plus 4 plus 27 over x minus 6. Number 3, it's 2x squared plus x plus 3 plus negative 13 over x plus 1. Number 4 is negative 86. 5 is A, 6 is B. So on this quiz, any questions about problem number 1?
Me too.
Everybody okay with number 1? So you want me to go over number 1? Okay, so let me go over number 1 first. In problem number 1, what you need to do is use long division. So you use long division. So here we have x squared minus 14x plus 3 divided by x minus 7. So you ask yourself, what times x equals to x squared, and that is x. Then you distribute. X times x is x squared. X times negative 7, that's negative 7x. Then you change the sign, negative, positive, combine after that, and that would be negative 7x. Then bring the 3 down, so it's plus 3. Then it's what number multiplied by x? It's negative 7x. And that's negative 7. So it's negative 7 times x is negative 7x. Negative 7 times negative 7 is positive 49. Then you change the signs. Positive, this becomes negative. Then you combine the numbers. So that would be negative 46. So in polynomial form, that would be f of x equals, then you multiply x minus 7 times x minus 7, and then plus negative 46 over the divisor, which is x minus 7. So that actually is the same thing as saying x minus 7 quantity square, yes, plus negative 46, or just minus 46. So you can just leave it like that, minus 46. Come on. And this is a polynomial form. You can just leave it like that. So you don't really need to have this on polynomial form. Like that. And that was C. Okay. Now problem number 2. On problem number 2,
Yes.
it's you divide it, and this is again long division. So this is x squared minus 2x plus 3. Is that the number 2 on this version or the other version? Is this version? Okay. So either way, just in case, it's the same concept, okay? So x times x is x squared. X times negative 6 is negative 6x. Then you change the sign. Combine the terms. This is 4x. Bring the 3 down. And then 4 times x is 4x. 4 times negative 6 is negative 24. Then you change the signs. When you combine that, that becomes 27. And if you want it in fractional form, you're going to put the quotient. So it's f of x equals x plus 4, and then plus the remainder, which is 27, over the divisor, which is x minus 6. And this is a fractional form. Okay. Now problem number 3, synthetic division. You want me to go over synthetic division, or are you okay with that? Yes, synthetic division. So problem number 3, synthetic division. You get the coefficients, which is 2, 3, 4, and negative 10. Notice that you have to check that goes in descending order. 3, 2, 1, and 0 on the exponents, okay? So once you get the coefficients, then you divide it by the opposite of whatever is on the denominator, which is -1. You put a line underneath, bring the first number down, so it's a 2 times -1, -2, then is 1 times -1, -1, 4 minus 1 is 3 times -1, -3, and then you combine, that is -13. See, that's a remainder. So when you put your answer, see the answer, you don't, you have to be careful because this right here, it's, see the first one is x to the, was it third power? Yes, right? So the answer is going to be to the second power. And then it's plus 1x, and then it's plus 3. So when you write your answer, it's going to be f of x divided by d of x. It would be 2x squared plus x plus 3, and then plus the remainder divided by the divisor. And that's what you got to do. Okay? That's how you have to do. And then for number 4, when they ask you for the remainder, all you have to do is use synthetic division. So it's 2, -3, 5, 10, divided by -3. You don't change the sign of that because that's already k. That's like x equals that. Then you bring the first number down. 2 times -3 is -6. Combine it is -9. Times -3, it's positive 27. Plus 5 is 32. That's you. 32 times -3, it's -96. And when you combine that, that's -86. And that is the answer. So what is the remainder? The remainder is just -86. That's what you gotta do. And then for number 5, it says find the use the factor theorem to determine if the first polynomial is a factor of the second one. How would you determine if it's a factor of the second one? What are you expecting to get? Remainder of 0. That's right. So then as you check number 5, see this is 8, 17, -2, 1, and 4. When you divide that by the opposite of x plus 2, it's -2. And you divide by using synthetic division. 8 times -2 is -16. This is positive 1. Positive 1 times -2, it's -2. Combine is -4. Times -2 is positive 8. Plus 1 is 9. 9 times -2 is -18. And when you combine, that is -14. So since you have a remainder, it's not a factor. Then the second one, it happens to be that the remainder would be 0. So it is, okay? Now, on the second page, here, many of you knew that the solutions, the real solutions, were -2 and positive 6. And many of you are using synthetic division, and you divided the polynomial by -2, so 7, -39, -40, and 132. And you went ahead and you divided. So you did everything, step by step. But at the end, you didn't know how to conclude it. I think that was a problem. So it's 7. 7 times -2 is -14. When you combine, that is -53. Times -2, that is positive 106. And then when you combine, that would be 66 times -2 is -132. So it's supposed to be a 0 remainder because it was a factor. Then from there, you divide. You keep dividing. You don't divide it separately. You keep dividing now by the second 0, which is 6. You bring the first number down, which is 7. Times 6 is 42. Combine it with the -53, it's -11. Times 6 is -66. And it was expected that the remainder was going to be 0. Then after that, you have to go back and say, well, this is supposed to be to the third power, right? Then this is to the second power, and the last one is just x. So this is a factor that you were looking for, which is 11/7, and 11/7 is like 1 4/7. So that's what that 0 indicates that it is. So it's this right here. So all you have to do after you find the factor is just put it along with the other two factors. So it's f of x is x plus 2 times x minus 6 times 7x minus 11. And that was the answer. Okay? Separately. And the thing is that when you divide it separately, you don't really know what the remainder factor would be. So be careful with that, okay? Now, number 8. On problem number 8, some of you miss number 8. Please try not to miss, especially problems like this. To find the list of all the potential rational zeros, you have to use P over Q. P is the last number, is the coefficient, is the constant term, and Q is the coefficient of the leading term. So if you have P is 27, and Q is 3, then you have to get all the factors of 27. So the factors of 27, let me just bring this down. That's right, positive negative 1, positive negative 3, positive negative 9, and positive negative 27. Those are the factors for the 27. And now for the 3. Okay, on the bottom, it's positive negative 1 and positive negative 3. As you make combinations, see all these numbers divided by 1 is just all these numbers. But then as you combine 1 with the 3, that's going to be 1/3. So we have to add that 1/3 to the list. Then 3 divided by 3 is 1, 9 divided by 3 is 3, and 27 divided by 3, it's 9. So those are the numbers that were already a part of the list. So then the answer is all of them on the numerator plus 1/3. And that was C. Okay, which is this one. Yeah. So the 1/3 is when you divide the 1 by the 3. That's how it comes. Now, why did you do that? You have to get all the combinations, all these numbers divided by 1, and then all these numbers divided by 3. And that's the list. That is part of the theorem. The theorem, that's what it says. The theorem says when you want the list of all the potential, the ones that are possible to be zeros, get the P over the Q and get all the factors and all the factors of the denominator and do all the combinations. All the factors by the first one, all the factors by the second one. Simplify that, and that will give the list of all the potential real zeros. Yes. Now for number 9. In number 9, it says find all the rational zeros. So again, you have to start with the P over the Q. P is 14, Q is 1. So the list of factors are 1, 2, 7, and 14. And see, the 1 is just plus minus 1, which is all of those. And like I said, I was going to give you something that was closer to like the smallest numbers. As you try the first one, the 1, you see the 1 didn't work. Then when you try the negative 1 and you divide by the negative 1, let me move this over. Over here. Okay, so as you try the 1, it's 1, negative 1. Negative 1 divided by 1. Negative 8, 5, and 14. And you divided 1 times negative 1 is negative 1. Negative 9 times negative, it's positive 9. 14 times negative 1 is negative 14. That's a remainder 0. Now, since you already found one of the zeros, then you use those numbers, the 1, negative 9, and 14. So use a 1, negative 9, and 14, and you want to divide it by the next possible solution, which is 2. So you divide it by 2. 1 times 2 is 2. Negative 7 times 2 is negative 14. And then you continue. You try negative 2, and then the 7, it would be the next one. The negative 2 doesn't work. As you try it with, well, in this case, see, I already have the answer, right? I don't have to try another one. Because, as you can see, this is x to the 3rd power. this is x to the second power, so this is just x. So one solution, x equals -1, x equals 2, and the last solution is when you put x minus 7 equals to 0, you solve for the x, and x is equals to 7. And there's your third 0, okay? And then number 10, you do basically the same thing. You know, you get the p over the q, and then you get your possible solutions. As soon as you find one, which was a 4, okay? When you divide by 4, this is 4, -16, 1, and 4. See, some of you found that 4 was a solution, but that you didn't know what to do after that. Well, what you need to do, this is 0, 1, okay, 4 times 4 is 16, 0, that is 0, 1 times 4 is 4. It's supposed to be negative. Okay, so then as soon as you find one solution, okay, this polynomial, the original is x to the third power. Then the answer is to the second power. And you don't have an x here, 0x. So that would help you to find the other two solutions. See, when you rewrite it, 4x squared minus 1 equals to 0, and you find the solution by solving for x. Some of you forgot. See, some of you got up to this step right here. But then after this, you said x equals 1/2. And you were missing one solution. What was that solution? The -1/2. Every time you get the square root of a number, don't forget to put plus, minus the answer. So that's where the other one was missing, because of the square root being a positive and a negative. So that's how you get the plus minus 1/2, okay? Any questions about 2.4? No? Okay.